So we want to choose 4 blue and 2 red. So there are 9 blues and we want to choose 4 of them. And there are 5 reds and we want to choose 2 of them. So this number of ways to choose the blues, this number of ways to choose the reds, this times that, give me the number of ways to do all that. So we do that, that's 126 times 10 gives something. And then on the bottom, for our second part, just making our probability in the 2 combination problems, how many ways total are there to choose 16 things out of 14? Well, if you have 14 and you want to choose 6 of them, that many ways. So that's going to be 3003. And when you multiply this out and reduce it, you get 60 over 143. Now, notice this one kind of had, well, it didn't have to be done this way, but this is definitely the cleanest way to do this. You couldn't have done something like 9 over 14, that's a blue, and then 8 over 13, another blue, and 7 over 12, that's another blue, and then 6 over 11, another blue, and then saying, okay, now I got 5 reds out of 10, then 4, then 3, oops, no, I'm just choosing 6, right? So this would have been, and they rigged this when you're first learning probability, like in elementary school books, they say the probability of getting 4 blues, then 2 reds, right? If this had been, the order kind of matters here, right? You do blue, then blue, then blue, then blue, then red, that's the probability. But we didn't care what order we chose those blue fireworks, so you could have to multiply this by the number of ways to order your fireworks. So it's a little bit easier to just kind of go that way. Notice also, I think the first time I tried to do this, I tried to do it with a binomial. Silly me. I tried to do something like there are 9 out of 14 probability of getting a blue, I want 4 of those, and saying there are 5 out of 14 ways of getting a red, and I want to choose 2 of those, and there are 6, but that would be that order kind of mattering, and saying 6 choose 4 ways to choose the blue. I can't do this. Why can't I do this? The reds and the blues aren't independent, for the very reason whenever I pick a blue, I can't pick a blue again. Why those numbers are going down. Binomial only works if it's independent. So you probably didn't fall for that, but for some reason I fell for it for 2 seconds, so I thought maybe someone else did too. You can't do that for problems where the picks aren't independent of each other. If we had an infinite number of blues and an infinite number of reds, and the probability of getting a blue is 9/14 every time, then you could do that. Yes, but this case, no.